Hello, everyone, and welcome to Talk Nerdy. Today is Monday, February 12th, and I'm your host, Cara Santa Maria. Now, before we dive into today's episode, I want to thank those of you who made Talk Nerdy possible this week. Remember, Talk Nerdy is and will always be 100% free to download, and that's because of support from listeners just like you. This week, I want to thank Phil T-Bear, David J.E. Smith, Pedro M. Rosario Barbosa, Jeffrey Perez, Charles Payette, Jonathan Wright, Christian Jeffrey, The Honorable Husband, Jafe, Gabriel Felipe Jaramillo Gonzalez, Brian Holden, and of course, Jeffrey Sewell. If you want to hear your name read at the top of the show, just go to www.patreon.com/talknerdy, and there you can learn all about how to support the podcast. All right, guys, this week it's a good one. I get to talk to Dr. Amanda Hendrix. She's a planetary scientist. She was at NASA's JPL for 12 years. She was a principal investigator on the Hubble Space Telescope observing program. Gosh, on Cassini, you guys, we're going to dive really deep into Cassini. No pun intended. We're going to talk a lot about Saturn and Saturn's moons, but especially we're going to talk about her new book, Beyond Earth, Our Path to a New Home in the Planets, which she co-authored with Charles Wohlforth. So, you know what? Without any further ado, here she is, Dr. Amanda Hendrix. Well, Amanda, thank you so much for joining me today.
Well, thanks for having me. It's fun. This is fun to be here.
Absolutely. So I'm really excited to dive into your book, but mostly because I'm super excited about the arguments that you and, how do you pronounce your co-writer's name? Charles Wohlforth?
Wohlforth.
Wohlforth, yes. That you guys write about, because they're deeply based in a lot of the work that you've done over the years. So you're I guess technically a planetary scientist.
That's right.
And so how's that different from astrophysics?
Well, the work that I do is pretty much focused within our solar system. And astrophysics people, I think, do stuff outside of the solar system, stars and galaxies and whatnot.
Gotcha. So sort of that border of, what do we call that border? I know that when Voyager flew through it, we talked about that a lot.
Right. One of the Voyagers left the heliosphere.
Heliosphere. So that's the bubble around the sun.
Exactly.
Gotcha.
Of the magnetic influence of the sun.
And is that how we define the edge of our solar system, or is that sort of a nebulous, haha, no pun intended. Is that sort of a fuzzy boundary?
I'd say that's kind of what I think of as the edge of the solar system. Other people might think, oh, well, Pluto and kind of the interior edge of the Kuiper Belt are the edge of the solar system. But I think pretty much, if you think about it, the solar system is formed around our sun. And so if you go past the influence of the sun, you're going to not be in our solar system anymore. That's how I think about it.
Yeah, I mean, it's called the solar system for a reason, right? Yeah. So, and it's funny because we use that term colloquially when we talk about other quote unquote solar systems, but really those are just other stellar systems. Yeah. So you focus on what's happening sort of in our backyard. But of course, I think sometimes we forget because we watch television shows with gorgeous Hubble imagery and we think about things that happen really far away. But the truth of the matter is the solar system itself is damn big.
It's really big. And also there's a lot of action going on here. There's so much interesting stuff going on right in our own backyard. So, I mean, it's really important and interesting to, use Hubble and other techniques to do astrophysics. But I think that our solar system is where it's at.
Yeah.
And even looking for, life and finding other places for humans to live, we don't have to go beyond our own solar system, I don't think.
So that's, I think, a really cool conversation to be had. We've talked, I don't know, actually, thinking back, if I've had any astrobiologists. No, I have. I've had one astrobiologist on the show before, and I'm definitely friends with other astrobiologists who I've been trying to peg down to get on the show. And some of them have their favorites. Some people are really into Europa and they think that that's the best possible place to find life in our backyard. You focus specifically on Saturn's moons, not Jupiter's moons, with regard to just a lot of really interesting science that you found there. So what is it about Saturn that's so gripping for you?
Okay, well, first of all, the Cassini mission The spacecraft itself was in Saturn orbit from 2004 until just last year, 2017. And it was such an awesome mission. It did so much. And it really told us a lot about the whole Saturn system, the planet itself and the rings and the magnetospheric environment and all those wonderful moons. And so now we have a much better picture of all those moons and how they're each uniquely different. And as it turns out, and we had some clues about this before Cassini got there, but this really helped us learn more about these two special moons, Enceladus and Titan. And these are really important astrobiological targets for their own reasons. They both have subsurface oceans, as it turns out. Now, we know that there's other moons with subsurface oceans, like Europa and Ganymede in the Jovian system. The special thing about Enceladus is that it's spitting its ocean material right out at us via this south polar plume that it has. So it's actually got active, kind of like geyser activity at the South Pole. And
interesting.
Water vapor and water little particles are spewing out constantly.
Oh, wow. Because I know that we've seen that there are like these mini geysers on Europa, but they're kind of intermittent. Enceladus has a constant plume. It's
a constant plume. And
cool.
it is definitely a sure thing. The Europa plumes are... we still have a lot to learn about them. And I think that the evidence is getting more solid, but we still really need to confirm those and really understand them, because if they're intermittent, how can that be? So we've got a lot of understanding to do there with Europa. But Enceladus kind of makes it easy for us because those plumes are just going off constantly. And the reason that's interesting, of course, is this water vapor and the water particles are coming directly from the subsurface ocean. So, and we know that there's organic material in there also. And so maybe this ocean is a place that harbors some form of life. Certainly, if it does, it's very simple form of life. But still, we can fly through that plume in theory and grab some of the material and see if it has any sort of foundational material for life in it.
Oh, man. And that would be so much easier to do like as an orbital kind of mission as opposed to landing or needing some sort of probe.
Or a drill.
Yeah. Or a drill, yeah. Is Enceladus encapsulated in ice?
Yes, it's an icy moon. Mm-hmm. It has an icy shell, and then below that is the ocean. And then below that is kind of a rocky core.
And is it thought that that ocean has sort of the... tidal forces that would be necessary to create enough energy for life?
Exactly, because you need some sort of energy or heat source to both keep the ocean liquid so that the water doesn't freeze into ice, but also to help life. And yes, the tidal energy is probably a good option for that, for supporting life. And then you've got the ingredients too, as I mentioned, the organics and so forth. So you don't have to go to Enceladus and drill down. You can just go through and scoop up some of the plume material and see what's in it. There's a good chance that that's still pretty hard, because maybe if there's any little bugs or any, cells in there, that they might be kind of few and far between. So you might want to do multiple fly-throughs of the plume. You might want to be really certain that you have your capture technique down pat so that you can understand, actually get enough material, and then also be sure that you can understand it. So it's not like it's super easy, but it's a good first step in understanding whether there's any sort of life forms in our solar system.
So I guess that makes me think, I'm imagining here on Earth, we have obviously a lot of life. We're teeming with life, really advanced life, all the way down to, unicellular life. And if some alien were to come by and take a sample of our ocean, it would be quite obvious that there was a rich sort of life force here on Earth. But if we were to take a sample of a plume at Enceladus, like what are the odds that we would happen to get enough material to tell us that there's something there? Is it quite likely that even if life, as we're talking about, probably very, very simple life, couldn't survive that sort of ejection into space, that the subcomponents, kind of the proteins or the nucleic acids that are necessary would still survive in some form?
I doubt it. I think the thinking is that, if you're flying through the plume and capturing whatever you can, that any life forms that you might find in there are going to be dead.
Yeah.
Because they're not going to survive outside of their ocean. It's not Jupiter's radiation environment by any means, but still Saturn has a radiation belt and, charged particles that get pretty energetic, and life forms can't really withstand that kind of environment for very long.
And so would it actually rip their component parts apart as well? Or would there be some sort of indication, some sort of fingerprint potentially that life did exist?
Right. I think that you could still see some fingerprint. And I always imagine it being on the cellular level. But, you can see, okay, that's a cell. It's not living anymore because it's been ejected out and it's in space, in vacuum, and in this radiation environment now. But, it was just wiggling around in the nice warm ocean not too long ago. Ugh. So it would still be really cool.
I know. I was just about to ask you, can you imagine? And you're like, yeah, I've dedicated my life to this. Of course I can imagine. But what does it feel like when you think about the fact that we're getting closer and closer within our lifetimes to potentially finding evidence of some other form of life?
It's really exciting because, you think back to the Viking days when Viking landed on Mars and everybody was excited about looking for life, and then nothing happened. And then since then, it's kind of been like nothing, like, oh my gosh, what did we do? What should we do next? And people had surmised about subsurface oceans at these outer solar system icy moons. Mm-hmm. But, I remember distinctly when the Europa subsurface ocean was discovered by instruments on the Galileo mission, that I feel like that just kind of broke the whole thing wide open all over again. Like, wow, okay.
Yeah. Yeah.
This is the place to be looking for life, because this is liquid water right now, not like eons ago. Right now, there could be life in here. So it's super exciting.
Absolutely. And, it's funny to think about Saturn. I guess it's, we've got 8 planets, potentially 9 now with Planet X. And it's all very confusing. We're still trying to figure all this out. And then there's all these Kuiper belt things that might as well be planets or might as well not be planets, but whatever.
Right. Planets anyway.
Yeah, there you go. In terms of the planets that we know about and that we've got a lot of really, hardcore research about, it's funny because I think your everyday average Joe or Jane walking down the street, we know they're up there or out there, however you want to say it. I don't know how often we really think about them. And I don't know how often we think about oh my gosh, this is what makes Mercury so special, or this is man on Neptune, this is what's going on. And so it's funny to me and super interesting when I meet somebody like yourself who's Saturn's where it's at. So what is it that really kind of made you fall in love? Was it those moons?
Oh, yeah, it's the moons. I mean, I'm a moon gal anyway. I like all moons in the solar system.
What about our own moon? Are you into our own moon?
Our own moon is very, very cool for so many reasons. I mean, I love studying Earth's moon. But, then the Jovian moons are awesome. And then the Saturnian moons are awesome. I mean,
they're called the Saturnian moons. I love that.
Well, yeah.
That's so cool.
And so, just working on Cassini and getting to know all the moons and getting to know how each of them is different and why they're different. And then, of course, Titan is the kind of the big mama in the system and is completely different from the rest of them.
Yeah, so really is Titan special. Like a gassy body? I'm looking at a picture of Titan. I can't make sense of what I'm seeing. It looks Earth-like.
Yeah. Oh my gosh, it's so Earth-like. That's why I love it. It's a icy moon.
Okay.
Because the bulk of it is water ice, although there's rocky interior material too. But this is why Titan is so special. It does have a thick atmosphere. And it's the only moon in the solar system that has a thick atmosphere like this. And so you look at it and you go, what am I looking at? And that's because we can't see through the atmosphere. It's very absorbing and it's full of haze like smog. And so our eyes actually can't see through to the surface.
Wow.
Yeah, it's bizarre. And, why does it have this thick atmosphere? It's a moon, not a planet. What's going on? And it's still kind of a remaining mystery that we still don't quite understand coming out of the Cassini mission about why Titan has this atmosphere, how it is maintained.
Man, that's so crazy. And Titan's just one of I can't even count. How many moons are around Saturn?
There's like, sometimes I lose track, but there's like 68 or something.
That's so crazy. So you worked on the Cassini mission, yes?
Oh, yes.
Yeah.
Yes.
So, and what was your role on that mission?
Well, I had a few roles. I did science planning of these icy satellite flybys. So we'd plan out what was happening on each of the flybys and like which instrument would be taking data and taking pictures and spectra. And I was deputy project scientist. And so kind of overseeing the science that was happening and kind of the balance of the science. So that was really neat. And then throughout, I have been and continue to be a co-investigator on the UVIS instrument, which is the ultraviolet imaging spectrograph. And so it's kind of a imaging spectrometer that we make images and take spectra of everything in the system, really. But I focus on the moons.
And so you said continue to be. Was that not part of the Cassini mission?
It is part of the Cassini mission, but there's still so much data to work on.
I see. So no longer collecting data, but still
right. Working
kind of pouring through it. Yeah.
Yeah.
So what was the experience like for you? I always love to get kind of the emotional angle on these things because Cassini, of course, came to its fiery end last year. And this was really big news. And a lot of people were really sad, like, that, their baby, especially I can imagine people who had been working on the mission and in many ways overseeing the mission for so long. What was that experience like for you?
It was pretty intense. It was sad. I try to be realistic about it because I know that we've got to end it at some point. We're losing resources on it. We want to send it out in a controlled way because if we just leave it in orbit around Saturn, which we could have done, it would stay in a pretty stable orbit, but eventually it could get perturbed enough that it could hit Enceladus or Titan, which, as we said, are astrobiologically interesting. So we can't let it crash into one of those places.
Yeah.
And so we had to dispose of it in a controlled way. And so putting it into the planet made the most sense. But still, even if you're thinking realistically about it, it's sad because it was such a big part of my life for 20 years.
Yeah. Wow.
And it'll continue to be part of my life because I will continue to work on the data. But to not see new images coming in every day and hear what's happening on the spacecraft and be thinking about which observations do we want to do next. And, we've got this Enceladus flyby coming up and what kind of data are we going to get? That kind of thing, it's just kind of the end of an era, definitely.
Absolutely. And, it's so funny because I think as people who aren't necessarily working on the science, but who get to enjoy the fruits of the labor of the scientists, what is so compelling to us, and I think what speaks to us the most, are the actual visual images.
Oh, yeah.
Are the things that come back. Yeah. And like seeing these things so up close, seeing detail on them that we never imagined possible. But of course, you get to look through that, not just at the visible light images, but like you said, at the spectral data, at the maybe infrared. There's all these different ways to image these things. Right.
And so on Cassini, we had lots of wavelength coverage. We had ultraviolet, which I focused on, clear up through mid-IR. And with over about 3 or 4 instruments in there. And then we had all of these other instruments looking at the plasma environment and the magnetospheric environment. So they're looking at energetic electrons and ions and colder, less energetic ions and electrons and where are they in the system. And then we had a dust detector because there's actually very fine grains of dust out there. I say dust, but what we really mostly mean is water ice particles.
Oh, okay.
And what's really interesting here is that this instrument is called CDA, which is the Cosmic Dust Analyzer. And it was very important because in the Saturn system, you know the main rings, the beautiful main rings around the planet. But what's really important is that there's this other ring called the E ring that you really can't see. And so you can't really see it in the images, except for some of those famous, beautiful images where you see the planet backlit and you can see the sunlight coming through the rings.
Okay.
Those are beautiful images. And there you can see the E ring. And you have to see it backlit because the particles are so fine. They're like 1 to 5 microns. So seeing it by just looking at it with your eyes, it's hard to see it.
And it's wider than the inner rings?
It's much wider.
Okay. All right.
It extends way out, probably about to 10 Saturn radii or more.
Oh, wow.
And it's very fine grains of dust, and they all come from the Enceladus plumes. So
No
Enceladus
way.
plumes are spewing out the water vapor and water grains, and a lot of them, most of them, fall back onto the surface of Enceladus, but a lot of them are lost to Enceladus's weak gravity and make up this E-ring of very fine grains. And what I have continued to find very interesting is that all of the moons, Mimas, Enceladus, Tethys, Dione, Rhea, so these are the kind of the main inner moons, they all orbit Saturn within this E-ring. And so you can imagine that you're orbiting Saturn, you're not just in space, but you're moving around through kind of a cloud of very fine, dusty water ice particles.
And so is that constantly smashing them up?
Constantly smashed. Well, it doesn't smash them up, but it lands on them.
Oh, I see. Okay.
And depending on the relative velocity of the particles, it can kind of sandblast the surface a little bit. But certainly, it helps all this almost pure water ice in the E-ring hitting these surfaces helps to keep these moons pretty bright. Their albedos, which is the amount of light that reflects off of them, are pretty high compared to, say, the Jovian moons, which are kind of dark. But you look at the Saturnian moons, and they're really quite bright. And so that's always been kind of a mystery. Well, why do they have such high albedos? And especially Enceladus, it's got the highest albedo of anything in the solar system. And that's always been kind of a clue that maybe something was going on there. Like it's getting resurfaced somehow, because it's not getting darker with age like we expect most things to do, because they accumulate gunk, meteoritic material over time. It's just staying very, very bright. And sure enough, Enceladus has got these plumes. It's making this E-ring, and those E-ring grains coat the rest of the moons and keep them pretty bright too.
Gosh, it's so like I basically, as I'm talking to you, just have images of all of these different Saturnian moons. And I'm seeing that like there are moons that were just discovered like a few years ago.
Oh, I know.
And there are moons, it's like, and some of them look like food, like some look like ravioli and other ones look like marshmallows. Yeah, it's really weird. And it just makes me think, gosh, there's so much that
stuff out there.
It's so bizarre to me when people have a sort of cynical view of modern science, like, oh, we've discovered everything there's to discover, or blah, blah, blah. It's like, what are you talking about? It's amazing.
And so it also makes me wonder, well, you know what? We've never been to Neptune or Uranus. What are we going to find when we go there?
Oh, I know.
We need to do Cassini at Neptune for sure, and Uranus. But I like Neptune because I like Triton, the moon Triton. Yeah.
So you're not a Saturn purist. You're an equal opportunity moon researcher. But Cassini just gave like loads of data.
Oh, so much. So, I mean, people are going to be working through these data for years and years, and it's great for future students, like grad students who need a thesis project, because there's just so many ideas just waiting to be had in these data sets. I love it.
Absolutely.
Yeah.
Oh, and so are you still working at NASA? Do you have a joint appointment with NASA? Like, what's your kind of role now in the science world?
I'm a planetary scientist. Most of my funding comes through NASA grants.
Okay.
So, but I'm with Planetary Science Institute. I was at JPL for about 12 years. And then I decided to go it on my own, not really on my own, but
maybe a little less bureaucracy.
Just a little bit.
Yeah. And JPL is interesting too, because it's like public-private, because it's NASA, but it's also Caltech. And it's a weird, cool machine that a lot of really brilliant minds have dedicated their lives to.
Oh, yeah, it's neat. And there's so much going on there. So many projects happening, projects in the works, projects just being thought of and being, sort of mission concepts being discussed, and, people are trying to figure them out. So it's pretty dynamic.
Yeah, absolutely. But now you get to maybe have a little bit more control over the things that you're focusing on.
Oh, yeah. It's very nice. I get to do whatever I want. And, but, I do need to go out and write grant proposals.
Yeah.
And to bring my funding in.
And publish.
Yes.
And so you're still looking at some of that Cassini data, but what other like cool projects are you working on?
Well, there's a few. I also work on the Lunar Reconnaissance Orbiter, which is in orbit around the moon.
Mm-hmm.
And it's been in orbit since 2009. And it's really great because there's still so much that we don't know about our own moon, which is funny to me because I feel like we've sent a lot of instruments out to the Saturn system, and we haven't sent those same instruments to the moon yet. So there's still a lot we need to know about the moon. The thing that I'm interested in about the moon mostly is the water topic, because we do know that there's water at the moon now. Mm-hmm. And we're using this one instrument on LRO to study water on the moon. And it's kind of a novel way where we're using ultraviolet light. There's a diagnostic spectral absorption feature that water ice produces in the ultraviolet. And so we can look for that across the moon. And we can even look in these permanently shadowed regions at the poles that never get light. So they're super cold and they're permanently shadowed. So sunlight does not get in there. So it's always been hard to look and see what's in there. But if you use ultraviolet light that's coming from interplanetary hydrogen and also stars producing ultraviolet light, they're coming from all directions. And so we can use that as a source of light to look into these permanently shadowed regions and see the light that gets reflected out.
Gosh, isn't it weird that sense? Absolutely. I'm just thinking about how we don't even know what's going on with our own moon. I mean, we do, but we don't.
Yeah, there's still a lot of questions. And it's just a fascinating place. It's really, there's this kind of new push to go back to the moon and maybe send humans to the moon. And I'm all for it. I think, the moon is a good place to go. And, we need to send a rover to the moon and maybe go up to those permanently shadowed regions and check them out. And there's this big, giant impact basin that you can't really see because it's on the far side of the moon, kind of towards the South Pole. And it's called South Pole Aitken Basin. And it's got a lot of interesting stuff going on, like weird, swirly patterns in it. It's got weird compositional variations. And then, of course, it's next to the South Pole. So you've got some permanently shadowed regions not too far. So that would be a really neat place to send a mission here before too long. So I don't know, a lot of interesting stuff at the moon.
Yeah. I mean, and there's so much work to do. I actually have a friend, I think she was on the podcast in the really early days, maybe before episode 50, named Meg Rosenberg, who got her PhD at Caltech. And her PhD is in moon craters. She's a planetary scientist and she dedicated her entire academic career to moon craters. You know what I mean? It's this is just all she did. And it's amazing that we still have a whole bunch to learn about the craters on the moon.
Right. And the moon is interesting, and thinking about craters on the moon is interesting because it's kind of we've got samples from the moon. And so that gives us sort of ground truth for what we are seeing by looking at telescopes or even spacecraft at the moon.
I love that phrase. Yeah. That's so good. It's confirmational evidence.
Exactly. So now we know, yes, we think we know what we're seeing through the telescope. And we just confirmed it because we brought a sample back. Mm-hmm. And so now we can say, well, if I look through a telescope at an asteroid, I have a pretty good idea that what I'm seeing is right because that worked at the moon. That doesn't mean that we don't need to bring samples back from asteroids and other places because that's 10 or 100 or 1,000 times more information than we even think we're going to get. So the moon is special for that reason. And then also just to look at the craters. Because understanding the impactor population throughout time, as indicated by looking at the moon's surface, because all of those impacts there are just recorded. And so we have kind of a history of impactors going back at least, a certain distance in time, because the moon just shows all of its craters. They don't get weathered away by wind and rain like they do on the Earth. They don't have oceans covering them up like here on Earth. And so that gives us an idea of what was happening in the early solar system when all these impactors were flying around and making planets and destroying planetesimals and so forth. So still a lot to learn about the moon and then what that tells us about our own Earth, the early Earth environment, and the early solar system.
Absolutely. And, I don't want to turn this into a Mars bashing session because I love Mars and I know everybody loves Mars and Mars is a very important place to study. But why do you think that culturally there's this obsession with Mars? Is it just because we've been to the moon and it feels old hat and Mars is like the next kind of somewhat reasonable place that we could get to?
Yes, and I think it started even before that because, back with early in the 1800s telescopic observations of Mars showing, it looks like there's canals there. Maybe there's some sort of alien beings living on Mars. I think that really started people getting interested in Mars and the idea of life on Mars. And now we have done a ton there, and it's great.
It is great. It's great.
And I do think that it is a good next destination for humans. I think, going back to the moon is a good idea with humans. And I think that going to Mars is a good idea. Going to Mars is really hard.
Yes.
That's why we haven't done it yet. And hard equals expensive.
Yes. And also potentially really dangerous in the sort of psychological way that we don't always talk about. But I think, The Martian as a book and as a film hit on it. And I think that, those conversations are being had all the time at space agencies. But in popular culture, it's like, oh, yeah, it's a one-way ticket. And then we just don't talk about it anymore. But it's like,
right.
It's like some real risk involved, like some real legitimate, the people who decide to be the first have a very good chance of not making it. And that's an analysis that I think some agencies aren't willing to make that risk yet.
Right. And that's why we haven't gone yet, because doing something about that risk, protecting ourselves against those risks becomes very expensive.
Yeah.
And you're exactly right. So there's a lot of risks involved, not only just, not making it or crashing, but just the whole radiation environment.
Absolutely.
It's very deadly.
I mean, it's dangerous for our astronauts that spend time on the ISS. I don't think that we really take the time, every so often a new news story will come up that's like, oh yeah, spending time in, microgravity crushes your optic nerves, or, oh yeah, their brain case is smaller than it used to be. It's like, whoa, okay, well that doesn't sound good. Oh yeah, they can't really walk when they land. But there are also, I know a few astronauts personally, and, a lot of them have had small carcinomas removed, and they've had to deal with some of these real issues of being in that radiation environment.
Right. And that's at low Earth orbit, where you're partially shielded.
Yep.
But on your way to Mars, there is nothing.
Yeah.
And on the surface of Mars, there's pretty much nothing. So.
And we just don't, we don't have our head fully wrapped around using sunscreen on Earth, It's kind of still a big disconnect there.
It's a little bit more than that, too.
Yeah. It's so funny to me thinking about the psychology of astrobiology, the psychology of space travel, the psychology of planetary science, where we really did evolve and learn and grow and develop in this very structured, prescribed environment of Earth. And it's what we know. And it's the perspective that we have been basically programmed to think from. And getting outside of that takes so much creativity.
Right. You're right. And yet, don't you think that humans are also sort of programmed to want to check it out out there?
Yeah, right. It's so fundamental, this this nature of exploration. But it's funny because I think that a lot of times people incorrectly think of science as very rigid, as not at all creative, as this endeavor that, doesn't require any humanity. And it's like nothing could be further from the truth.
Oh, right. Oh, yeah. It requires a lot of creativity to think of different ways of doing things, because you've got to if you're going to a completely different environment. Mm-hmm. It makes it fun, actually.
Yeah. It sounds like you have had a really, really fun job throughout your life. And
oh, yeah.
I'm really lucky that we get to sit here and learn from all of the incredible things that you have been able to discover throughout your time. So I'd feel bad if we didn't dive into the book. I know that we've kind of touched on some of the things that you talk about in the book, but you specifically it's called Beyond Earth, Our Path to a New Home in the Planet. So you're specifically focusing on this planetary view, this solar system view, but you talk specifically about Saturn, don't you?
Oh, yes. Well, what we wanted to do with the book was think about all of the issues surrounding setting up a human settlement in the solar system, and where would it be a good place to do that, and how realistic would it be? Because we decided we're not going to think about, colonizing somewhere outside of our solar system. We want to be somewhat reality grounded, and going outside of our solar system with humans right now is not in reality right now.
Yeah.
As we just talked about, even going to Mars is not a reality right now, but at least it's on the horizon. So we thought about, well, where in the solar system could we actually go and establish a human settlement? Where would that actually work? And we decided against Mars, and it's because of this radiation environment. So Mars has a little bit of shielding to its surface from its atmosphere, but the atmosphere is really thin. So if you were to go there, or when humans do go there, if they're going to spend any time, they're going to need to have some sort of shielded shelters, which may well involve living underground, because some level of Martian dirt does provide adequate shielding.
I see.
But
so
then you got to live underground.
Absolutely. You go to a whole other planet just to live underground.
Right.
Yeah. I mean, that's the thing that the Martian got wrong intentionally. Like Andy Weir talks about how when he wrote about it, it was sort of like, yeah, I know that this could never happen, but
we're just going to skip that.
Yeah. But that first dust storm could not actually have happened on Mars.
Right. It was a little too strong.
Too
strong.
A
little dramatic.
Yeah. Because the atmosphere just couldn't sustain that.
Right. I mean, there are dust storms. Yeah. But not quite that intense.
Yeah. Like you could walk through them. No problem.
I imagine.
except, all the cancer. It's like something you have to be careful of. Except that. Yeah. So it's interesting because we think of Mars as the low-hanging fruit because it's so close.
Right.
But that doesn't necessarily mean that it's the most livable. Yes, habitable.
Habitable. And so, but Titan, on the other hand, as I mentioned, it's the only moon in the solar system with this thick atmosphere. And that atmosphere absorbs basically all of the radiation that hits the top of it. And the main kind of radiation that we're worried about here is cosmic rays.
Okay.
These are very energetic. And unlike solar radiation, where you hear about, there's a solar storm, and so it's going to be at Saturn in 2 days, everybody take cover. You can shield against that because you know when it's coming, and the radiation is a little less energetic. Mm-hmm. But cosmic rays are coming from every direction, and they're kind of constant. And so it's not like a storm and you can predict them. Oh. And also they're super energetic.
So how energetic? Are we talking like gamma rays?
Yeah. And I'd have to double check on, how many EVs exactly.
That's okay. That would not compute anyway. Okay. I'd be like, sure, I'll take your word for it. But so that's kind of as bad as it gets, right?
Yes.
Yeah.
But it's really bad, but none of those cosmic rays make it to the surface of Titan.
Oh,
and so
okay. Because of the atmosphere.
They get absorbed. And so it's this natural shield. And so that is the number one reason that Titan is so great for a future human destination.
Oh, cool.
But there's lots of other reasons too.
Okay.
We already touched on a little bit how Earth-like it is. I mean, it's kind of, I would say definitely it is the most Earth-like place in the solar system. I don't know why people sometimes think Mars is Earth-like.
No, I think it's just because it's like, I don't know, it's a rock. And we think of Earth as a rock, I guess. But
Titan is basically, rocky. It's icy, but ice at those temperatures acts like a rock.
Yeah, and we have that here, right? Like, how different would it be from like the middle of Antarctica?
It would be colder.
Okay.
But it would still be not unlike that. Gotcha. The big difference, if you're picturing like white snowfields, it would not look like that on Titan, because actually a lot of the surface is covered by what we call tholins, and they are organic. It's organic, rich kind of gunk that settles down out of the atmosphere. And it makes everything look kind of orangey, actually. So when you see pictures of Titan and you see the orange atmosphere, what you're seeing is the haze. And that haze, the actual haze particles, as they grow, they get bigger and bigger and kind of settle down onto the surface. And so you can see, I imagine that when humans get there, they will be able to find outcroppings of freshwater ice.
Oh, cool.
And then it's not far below the tholin covered surface. but it's not going to be bright white ice sheets like you see in Antarctica. And of course, the other thing is that you've got the thick atmosphere and it's 10 times farther than from the sun. And so the light is dim.
Yeah, so it's just not as warm. It's not as bright because it's so far
Not as
away
bright
from.
and it's not as warm. I mean, it's actually pretty effing cold.
But there's water that we could drink.
Yeah.
Like there's so matters. Like
that, yeah.
In Mars, we still don't have a very good idea about whether or not there is fresh water that we could tap into. Like, we're constantly finding new evidence of it, but it doesn't seem to be like the book is really closed. And also, it doesn't seem like we would know how to drink it.
And certainly there's water in varying amounts at the polar caps of Mars. But in Titan, most of the bulk of the body is made of water ice. So all you have to do is, kind of scrape off the Tholen stuff, and there's fresh water ice. And so what you have to do is melt it.
Oh, yeah, that's true. We'd have to have
all
heat.
the water's frozen.
Yep.
But that's easy enough. And all the water's frozen on Mars, too.
Yeah,
So.
that's true. And that Tholen stuff, is it Tholen with a TH or Folin with an F?
Tholen with a TH.
Tholen with a TH. Is that like nutritive? You said it's organic matter. Could we eat that stuff? Or I don't know, we'd get cancer.
Wouldn't.
Okay.
Matter of fact, it could be toxic.
Oh, okay. Good to know. Good to know. Does it provide any sort of evidence or indication of like these building blocks of life?
Well, okay. If there's any life on the surface of Titan in all this organic stuff, it would probably have to be methane-based life.
Oh,
so it
interesting.
Could be, it's life as we don't know it.
Yeah.
Because there's frozen water there, but there's not liquid water. And by the way, I should mention, though, that there are liquids on Titan. But again, it's liquid hydrocarbons. It's methane and ethane. And that's another reason that Titan's so fascinating is it's the only place in the whole entire solar system where there's stable liquid on the surface. And that's another way that it's Earth-like is there's lakes and seas on the surface. So you could, build a home next to the lake and have a little view if you wanted.
But it would smell like really bad.
Yeah, but who's going to take off their helmet? Because there's no oxygen. So you have to keep your helmet on.
Okay, good to know. Good to know. Yeah. So it'll smell like whatever air freshener you decide to put in your helmet.
Yeah.
Oh, it's so fascinating to think about all these little things. I can see how frustratingly exciting it must be to be a science advisor on a Hollywood movie, that takes place in one of these faraway lands.
Please don't do that. Please don't make them do that.
Yeah. It's like there's so many things to consider.
Yeah.
Eventually, you got to just skip over some of them, I think.
But, even though you can't eat the Tholins, there's other things that you can do with them.
Oh.
Like maybe, how we like to burn fossil fuels here on Earth and make energy. You can do that on Titan. So there's lots of different energy sources. So, and you've got to have some sort of source of energy because you need to keep warm.
Yeah, absolutely.
And you need to make the oxygen to breathe. Because the atmosphere, I didn't mention this, but the atmosphere is mostly nitrogen and with some methane in it and some other trace components. But there's no oxygen. And so you're going to have to make oxygen out of the water there.
Yeah.
Again, easy, not a big deal. But once you make the oxygen, you could combust methane or ethane and make energy. Or you could even do something like build a wind turbine, because there's the atmosphere, and so there's wind that we know, and you can use wind energy. And maybe you could even do things like use tidal energy or build a dam or something at one of those lakes and harness some of the energy in the liquids.
I love this, like the survival guide to Titan. So when we're outside looking in, and granted, we're still, I assume, pretty far away. The Cassini may have flown by pretty close to get some better imagery of Titan, and we can't really see down to the surface because of that thick atmosphere. If we were standing on the surface, would we be able to see stars? Would we even be able to see Saturn?
Yes.
Okay.
We would be able to see the sun for sure because it's bright. I don't know if we'd be able to see other stars.
Okay.
But our star, we'd certainly be able to see. And then we would be able to see Saturn, again, through the haze.
Oh, it'd be so weird.
And also, you'd have to be standing on the right side of Titan to see Saturn, because it's kind of like if you happen to build your home on the far side of the moon, you would never be able to see the Earth.
Oh, so
Same
is
with
it also, what do you call that? Tidally
phase
locked?
locked.
Phase locked. Yeah.
Or tidally locked. Yeah.
Yeah. So it always faces the same direction.
Yep.
Oh.
And also it's pretty much in the plane of the rings. So you would not be able, you'd be looking at the rings pretty much edge on.
Weird.
Yeah.
That is so cool.
Yeah.
So, you know, when I take my telescope out and I have like a pretty decent sort of deep sky telescope, it's a Celestron Nexstar 6, I think. And
Cool.
So when I take it out, I can see LA is hard, as you know, because we just have so much light pollution. But if I take it up to Joshua Tree, I see Saturn crystal clear. I can see the
awesome.
rings. It's really beautiful.
Isn't that awesome?
It's awesome. I see Jupiter really beautifully. I can see banding. I can see this the spot. Mars always looks like a fireball. Like I've never been able to see Mars through my That's just a telescope thing, isn't it? Like Mars always looks crappy through telescopes.
Well, and it does have stuff going on in the atmosphere and stuff. And I think, Hubble does a good job, but.
Yeah, Hubble does it. Yeah, it helps to be out there when you take your pictures.
And really big.
Yeah.
But can you see Jupiter's moons?
Yes,
then?
I can see 4 of them.
Yeah.
Yeah.
Well, that's what I mean.
The
Galilean satellites. Yeah. I love them. I think it's so neat to be able to see them, to actually see them. I mean.
Oh, yeah. It blows my mind. I've actually gotten one. I took a picture once with my iPhone. I don't even know how I pulled that off. And they were in like a perfect row.
Oh.
There's a name for that. They were in syzygy.
Yeah.
It was so cool. I learned that word during the eclipse. Oh, I have to ask, did you see the eclipse?
Of course.
Oh, good.
Of course. We went up to Wyoming and it was so awesome.
I know.
It was really neat.
I cried. Did you cry?
I didn't cry, but I was very excited. I was super excited.
I always wonder what would it be like to be in the head of somebody who really understands the kinds of things that I think a lot of us who are science communicators or just science, podcast listeners, science enthusiasts, like I think that we pride ourselves on doing our homework and on, really being excited by this kind of stuff. But somebody like yourself who's just really dedicated your life and has a deep understanding of these processes, and then you get to experience something like a solar eclipse. Like it must just resonate in a special way. It
was very special. But you know what? I have to say, and this might sound kind of corny, but the most special part of it was, I was at a school and having all the kids there and having them see it for the first time and get super excited about it. And I had given a little talk the night before to tell them about what was happening and why and what they might expect to see. And then we actually saw a lot of the phenomena that I talked about. And so that made it so neat to see everybody just super excited about it. And then, of course, everybody was talking about, when's the next one? I can't wait to sign up for the next one.
Like, well, time to get that plane ticket.
Right.
Yeah.
So, yeah, that was really neat. A neat experience.
I think I might be an eclipse chaser now. What do they call us? Umbrophiles. Might have to go down to South America next year. So cool. Okay, so obviously, Beyond Earth, this is sort of a guide, sort of a, I don't know, how would you describe it? It's not really a guide as much as a
I think
dive?
of it as, it's kind of a, and of course it's not really a story, but it's just kind of a thought experiment, really.
Yeah.
About what is it going to take to go to Titan? And what are the hurdles that we have to overcome? And also, I think what we were trying to do is let readers know, look, space is really hard. And, you read articles maybe, and we're on our way to Mars and journey to Mars. And, we're going to go pretty soon, except that it's really hard. And so sometimes you don't really hear about that. And I guess I wanted to help kind of let people understand, why haven't we gone to Mars yet? Why is it so hard? And yet, why is it so important to go out in space? Let's keep that as something that is important to, this country and other countries so that we can all work together. Because for these big projects, we're definitely going to have to work together because they're expensive and complicated. And also because it's a new environment now where we've got businesses like SpaceX doing their own thing, and we can really leverage that to make these projects actually happen. They're too big to just try to do just NASA alone.
Oh, for sure. For sure. And I luckily, NASA knows that.
Yeah,
I mean, you think about it, it's like NASA is the number one funder of SpaceX. You know what I mean? They're working together. This is not like a competition here. It's funny. I'm looking through the index. That's where I always find the good stuff. You're talking about all of the difficulties. Let's see how many passages there are for Congress, U.S.
Oh my God, I know.
And then let's see what else we've got. Birth control, important. How about bone density loss? Yeah, that's not a good thing. So there's definitely, it goes deep. And also I think something that's really important to say, because I know you won't say it because you wrote it, so it's okay, I'll say it for you. It is endlessly readable. Like, this is not an overly dense, super complicated textbook by any stretch. This is a really, really readable, it has like a good narrative vibe to it, and it's really, really compelling, you guys. So
good. I'm glad you think so.
Yes, yeah. So highly, highly recommend it.
We wanted to make it readable for people who maybe aren't space buffs, but we would like, to get them interested in it. But also, we figured a lot of the readers would already be space buffs. Yeah. So, we didn't want to kind of dumb it down too much. We really wanted to make it readable for a lot of different people.
Yeah, absolutely. I mean, for me, it's perfect because as much as I have people on the show to talk about space, my background is neuroscience and biology, and space is like interesting to me, but sometimes it gets so esoteric, and sometimes you get so caught up in like basically just wonky content that I'm like, I don't know what's happening anymore. I'm totally losing interest. But this kind of stuff I just love because I think it doesn't forget that we're human beings and that we are part of that equation. And I think that's what makes it so personally compelling.
Right. Okay, good.
Yeah. And so, okay, Amanda, I have to ask, I've kept you so long now, but I have to ask, I close every episode of the show asking my guests the exact same 2 questions. And whenever I forget, people like raise hell. So I don't want to forget today. So they're kind of big picture. Are you ready for them?
Okay.
All right.
Okay, I think so.
Cool. Okay. So I want you to think about the future, which obviously you do a lot in your work. And you can think about it in whatever context is meaningful or relevant to you. Right now, it can be, your own personal future. It can be the future of space travel, of science. It could be the future of, humanity as a whole. Actually, big picture for planetary scientists is like the future of the universe. So you can think about it in whatever context you want. But I want to know 2 things. The first question is, what keeps you up the most at night? What is the most disconcerting, maybe uncomfortable, depressing, worrisome? And then on the flip side of that, what are you actually really optimistic and excited and looking forward to? Okay,
let's see. It's hard to narrow both of those things down. So I'm going to say the first thing that kind of comes to my mind. The most worrisome thing, I think, a lot of it, I think, comes down to money, right? It's worrisome to me that there's so many neat places to go in the solar system. And again, I'm just thinking about our solar system. And really important to check out and learn about. And yet NASA's budget is so small. Yeah. And the planetary budget is just a fraction of that. And so it's so hard to do everything. And so one thing that's actually worrisome to me is, we put together a plan like, here's what's important to do in the next decade. And then when we end up doing one of those things, maybe we end up having to scale it back so much to make it cheaper that, Cassini is so great because it had almost all the instruments that we needed on it.
Yeah.
But now it's so hard to send and expensive. Again, hard is expensive, a Cassini-like mission to all the places in the solar system. So I'm not knocking sending a smaller spacecraft to someplace else. But when really what we need to do is send a bigger spacecraft with more capabilities, it's kind of like, we're only going to be answering like a fraction of the questions. Again, not the end of the world, but...
Because it's about the payload, right? It's about the instruments that are on board, and the more instruments, just the bigger the ship.
The bigger, the more fuel, the more expensive, the bigger the launch vehicle, the more expensive. Yeah, exactly. But on the flip side, what was the second question? The thing I'm most excited about?
Yeah, like what are you really looking forward to and hopeful about?
Right. Well, it's kind of related to that, is that there are so many places to go in the solar system that are so neat. And so practically any mission that we send anywhere is going to be awesome. Because it's going to be someplace new. We're going to learn new things. There's these missions that were recently selected to go to small bodies. Mm-hmm. There's these Trojan asteroids, which are Trojan asteroids, but they're not in the asteroid belt. They're out at Jupiter's orbit. And they're probably some of the oldest bodies in the solar system. And so there's a mission that's going to go there and check some of those out. And there's a new mission going to another asteroid called Psyche, which is really interesting and different. And so those are going to be awesome missions. And they're kind of smaller class missions too. So they're not, full-on Cassini flagship class missions, but they're going to do great stuff there. And, there's so many places to go in the solar system. And, some people think, oh, we've been to asteroids before. We've got Dawn at Ceres, and it was already at Vesta. And so we know about asteroids, but every single asteroid is a little different.
Yeah.
And each one, tells us different clues about the early solar system. And the same with comets, So there's just a lot of places to go. And so that makes me happy.
Absolutely. And the good news
so much
is
neat stuff to learn.
Yeah. And we are innovating and we are figuring out how to do things, bigger, stronger, faster, and cheaper. Like this is going to be old news by the time it airs, but during our interview, the Falcon Heavy was successfully launched. This is huge. The fact that the payload is that big and that heavy and that we are getting closer to being able to put as much up there as we need to be able to for some of these big missions. So we're getting there.
We're getting there. It's really happening. So,
well, gosh, Amanda, this was so much fun. Thank you for taking all this time out to chat with me today.
Oh, well, it's so fun. I mean, I love talking about this stuff, and it's great to talk to you about it. And so thank you for inviting me.
Absolutely. And guys, the book is Beyond Earth, Our Path to a New Home in the Planets. And it's out in paperback now, so you don't have to lug around the big hardcover if you don't want. And you can get it, obviously, wherever books are sold. And I'm going to make sure there's a link to the book in the show notes. Again, I'm so glad that we were able to do this chat. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.